Good evening, students. Are you enjoying your holidays? I think some of you are busy in games, sports, and different activities, and some are enjoying different programs in TV. It's good, but at the same time, you have to spare some amount of time for your study because this is the high time to earn knowledge. At your this age, memory power is maximum, but gradually the memory power decreases with age. Is it clear? Do you like games and sports? I think some of you like games and sports. Some of you like games and sports. Okay? And some of you have less interest. Okay? And some of you do not like any games and sports. Now, these different students can be compared to the different metals. Some metals are more reactive. And some metals are less reactive. And some metals are least reactive. Now, the students who like games and sports, they take part in different competitions whenever they get chance. And so, they are available in the playground. And similarly, those metals which are highly reactive or more reactive, as soon as they come in contact with other substances, they react to form respective compounds. So, more reactive metals are found in combined state as compound. Is it clear? As for example, say potassium. Potassium is highly reactive metal. When potassium comes in contact with oxygen, it reacts vigorously with oxygen to form potassium oxide. And similarly, sodium is also more reactive metal. So, when it comes in contact with oxygen, it reacts vigorously with oxygen to form sodium oxide. Okay, so we cannot keep sodium and potassium in open space because if it comes in contact with oxygen and immediately it will react to form their respective metal oxides. That is why sodium and potassium are kept immersed in kerosene such that they will not come in contact with oxygen. Okay, so you remember that more active metals are found in combined state as compound. As compounds. And you think about the students which have less interest in different games and sports, and generally they do not take part in different games and sports. But if their parents and other friends force them, then only they take part in different games and sports. And similarly here, the less active metals, generally they are not reacting with other substances. But whenever certain conditions will be available, then only the different metals react with different other substances. Okay, as for example, the magnesium. At normal condition, the magnesium will not react with oxygen. But if it is burnt in air, then magnesium will react with oxygen to form magnesium oxide. And at that time, magnesium will be available as magnesium oxide in nature. If this required condition won't be available, then magnesium will not react with oxygen to form magnesium oxide. So, you remember that less active metals are found either as compound or as element. Is it clear? So, you remember that for the reaction of less reactive metal, they need some conditions. If conditions will be available, and definitely they will react and form compounds. And at that time, that particular metals are found as compound in nature. And otherwise, these metals are found as element. So remember, they are found as compound or element in nature. And again, come to this group of students, they do not take part in any competition. And similarly, as these least reactive metals do not take part in any chemical reaction, so they are found as element in nature. Is it clear? So once again, you remember that some metals are highly reactive, some are less reactive, and some are least reactive. And those metals which are highly reactive, and generally they take part in chemical reactions and found as compound in nature. And those metals which are lesser reactive, they need some conditions for reactions. If conditions will be available, no doubt they will react and form compounds. At that time they will be available as compound, and otherwise they will be available as element. And those metals which are least reactive, they do not take part in chemical reaction. That is why they are always found in nature as element. And here you have to remember the reactivity series of metals. The metals are arranged in a series according to the decreasing order of their reactivity. Okay? The metals are arranged in a series according to the decreasing order of their reactivity. It means that the metals which are at the top of the reactivity series, they are the highly reactive, and the metals which are at the bottom of the reactivity series, they are the least reactive. And here you have to remember this particular series of metals where the metals are arranged in a sequence according to the decreasing order of their reactivity. And I have made a code which will help you to remember the reactivity series easily. But this particular code does not have any other meaning. Now, puska maji nitile kam sigo. Here, PO, that is potassium. Then S, sodium. Then Ca, calcium. Then M, magnesium. A, aluminium. Then Z, zinc. Then I, iron. Then Ni, that is nickel. Then Ti, that is tin. Then Le, lead. Then H, hydrogen. Then CO, copper. Then Me, mercury. Then Si, silver. And Geo, gold. and after gold there is platinum. Now here I am not including all the metals, and here I have listed only the commonly used metals. Okay, in between these metals, so many other metals are also there. Okay, for the timing, you remember this reactivity series of metal, and it will help you to understand the different chemical reactions easily. Okay, now once again, Puskamaji, Nitile Kam Sigo. And this particular group of words do not have any definite meaning. Simply, it will help to remember this arrangement of metals in decreasing order of their reactivity. Now, come to the point. Here, the sodium and potassium, they are highly reactive. So, they easily react with other substances as soon as they come in contact. But the calcium, magnesium, aluminium, zinc, they are lesser reactive than the sodium, potassium. Okay, so these metals do not react with other substances at normal condition. They need some conditions for the reactions. Okay, if conditions will be available, required conditions will be available, and no doubt definitely they will react. And the metals which are at the bottom of the reactivity series, and they are least reactive, and they do not react with other substances. And here one more important point, that hydrogen, it is not metal, it is non-metal. Okay, but it is placed along with other metals in the reactivity series, because the hydrogen also electropositive in nature. Already in my previous class I mentioned you that what is electropositive ion and what is electronegative ion. Okay, and metals are electropositive in nature. But although hydrogen is non-metal, but it is electropositive in nature. That is why it is placed along with the metals in the reactivity series, because its reactivity is similar as that of the metals. Clear? Now, today I am going to discuss about the reaction of metals with oxygen and the reaction of non-metals with oxygen. Now you see, already I have mentioned that potassium and sodium, they are the highly reactive metals. So, whenever these metals come in contact with oxygen, they react with oxygen vigorously at normal condition to form respective oxides. That potassium, when it comes in contact with oxygen, and immediately it forms potassium oxide. And similarly, sodium from sodium oxide at normal condition. But this calcium and magnesium, they are lesser reactive than sodium and potassium. This calcium and magnesium do not react with oxygen at normal condition. If we heat them slightly, if they are slightly heated, then they will react with oxygen to form their respective oxides. As for example, when calcium reacts with oxygen, it forms calcium oxide, and when magnesium reacts with oxygen, then magnesium oxide is formed. Okay, but calcium and magnesium should be slightly heated, then only they will react with oxygen to form their respective oxides. Otherwise, they will not react with oxygen. And again you see, the aluminium and zinc, they are lesser reactive than either calcium or magnesium. So, if they are slightly heated, then also they do not react with oxygen. If they are heated strongly, then only they react with oxygen to form respective oxides. Then aluminium reacts with oxygen to form aluminium oxide, and zinc reacts with oxygen to form zinc oxide. But here you have to remember the valencies, then only you will be able to write the formula. Okay, and again iron, it is lesser reactive than aluminium and zinc. If you heat iron, then also it will not react. Okay, it will not react with oxygen. Only if you put some iron fillings over the flame, then only they react with oxygen to form oxides. Okay, and another important point, if iron is kept in contact with moist air, then iron react with oxygen to form iron oxide, that is rust. So whenever we use different iron articles in our day-to-day life, and before storing them we dry it. Otherwise in the very next day you will see the layer of rust over the articles if you keep these articles moist. Okay, it means that at moist condition iron react with oxygen to form iron oxide, that is rust. Okay, and again here this elements, metal elements which are at the bottom of the reactivity series, they do not react with oxygen. Okay, I think this is clear to all of you. Now you remember some points regarding reactions of matter and oxygen. Then what are those? Number 1, metals react with oxygen to form metal oxide. Okay, metal oxide. Metal react with oxygen to form metal oxide. In other way you can write this way, metal plus oxygen gives metal oxides. When metals reacts with oxygen, then metal oxides are produced. Okay, now metal oxides are basic in nature. Metal oxides are basic in nature. So here you should know what are acid and what are base. So for that I think you remember those substances which release hydrogen ion when dissolved in water are called acid. Okay, those substances which release hydrogen ion when dissolved in water are called acid. And the taste of acid is sour. And it turns blue litmus paper to red. Okay, and there are so many characteristics and differences between acid and base. We will discuss all these things afterwards. And for that timing, you remember that acid are the substance which release hydrogen ions when dissolved in water. Okay, and acids are sour in taste and they turn blue litmus paper to red. And another important point you remember here, as I mentioned, that acids are the substances which release hydrogen ion when dissolved in water. So, to be an acid, that particular compound has to contain at least one hydrogen atom. As for example, this is hydrochloric acid. This is the formula of hydrochloric acid, and this is the formula of sulfuric acid. And this way, in all acids, you will get the presence of hydrogen atom. At least one, it may be more, but at least one hydrogen must be there in that particular compound. Then only it will behave like a acid in solution form. Okay, and easily you can understand that if there is hydrogen atom, then only they can release hydrogen ion. Otherwise, where from they will release hydrogen ion when dissolved in water? Is it clear? So you remember that to be a acid, that particular compound has to contain at least one hydrogen atom. And again, what are base? Those substances which release hydroxyl ion when dissolved in water are called base. Okay? Those substances which release hydroxyl ion or hydroxide ion when dissolved in water are called base. As for example, say sodium hydroxide, then magnesium hydroxide. Now here you see, base contains this hydroxyl group. So to be a base, there must be at least one hydroxyl group. Okay, so you remember that base are the substances which release hydroxyl ion when dissolved in water. Okay, and base are bitter in taste. Okay, base are bitter in taste and it is soapy in nature, and bases turn red litmus paper to blue. And for that, you just remember these points. Okay, now metal oxides are basic in nature. What does it mean? It means that the metal oxides behaves like base. Okay, already I mentioned you that base turn red litmus paper to blue. And here, metal oxide, suppose magnesium oxide. If magnesium oxide come in contact with moist litmus paper, then it will change the color of the litmus paper. Okay, if you bring a moist red litmus paper, okay, then it will convert the color of the litmus paper to blue. Okay, it's proved that it is basic in nature. Is it clear? So once again, you remember that when metal reacts with oxygen, then metal oxides are formed. And generally, metal oxides are basic in nature. Okay. Then metal oxides like zinc oxide, aluminium oxides, they show the properties of base as well as acid in different reactions. So they are known as amphoteric oxides. Amphoteric oxides. They are known as amphoteric oxides. Okay, in different reactions, the same metal oxide sometimes behaves like acid and sometimes behaves like base. Okay, so you remember that these two oxides behaves like acid and base in different chemical reactions, and so they are known as amphoteric oxides. Is it clear? So now you come to the reaction of non-metal with oxygen. And you know that there are different non-metals that hydrogen, oxygen, nitrogen, carbon, sulfur, phosphorus, etc., etc. Isn't it? Now, when the non-metal, okay, when the non-metals reacts with oxygen, okay, they form non-metallic oxide. Non-metallic oxide. When non-metals react with oxygen, then non-metallic oxides are formed. As for example, carbon. Okay, when carbon reacts with oxygen, generally carbon dioxide gas is formed. Okay, and when hydrogen reacts with oxygen, then water is formed. Okay, when sulfur reacts with oxygen, then sulfur dioxide is formed. When nitrogen reacts with oxygen, then nitrogen oxide is formed. Okay, when phosphorus reacts with oxygen, then phosphorus oxide is formed. Okay, so you remember that when non-metals react with oxygen, then the non-metallic oxides are formed. But some non-metals, as for example phosphorus, phosphorus reacts with oxygen vigorously. Okay, whenever phosphorus come in contact with oxygen, and immediately it reacts with oxygen. That is why phosphorus is kept immersed in water, such that it will not come in contact with oxygen. Okay, now another important point here you see, the non-metallic oxides are acidic in nature. Okay, non-metallic oxides are acidic in nature. Could you follow the point? Non-metallic oxides are acidic in nature, means the non-metallic oxide generally behaves like acid. That is why they are known as acidic in nature. And again here you see, whenever this non-metallic oxide reacts with water, they form acids. When non-metallic oxide reacts with water, then they form acid. Here you remember that non-metallic oxide, when it reacts with water, they form acid. Okay? And when metallic oxide reacts with water, they form base. Remember this. When non-metallic oxide reacts with water, then acids are formed, and when metallic oxide reacts with water, then bases are formed. Okay, so you remember that non-metallic oxides are acidic in nature, but there are few exceptions. That say water, you know about water? Water, carbon monoxide, nitrogen oxide, and these are neutral oxides. They do not show the behavior of acid or behavior of base. So they are known as neutral oxides. Okay, as for example water, the pH value of water is 7. If the pH value is lower than 7, then that particular substance is acidic in nature. If it is higher than 7, then that particular substance is basic in nature. Is it clear? So you remember that when non-metal reacts with oxygen, then non-metallic oxides are formed. These are non-metallic oxides: carbon dioxide, water, carbon monoxide, sulfur dioxide. All these are non-metallic oxides. And non-metallic oxides are acidic in nature, means non-metallic oxide behaves like acid. And whenever non-metallic oxide reacts with water, they form acid. Okay, and you know that there are so many non-metallic oxides available in our atmosphere, like this carbon dioxide, sulfur dioxide, etc. And when they come in contact with rainwater, they react and form acid. And this is the main reason of forming acid rain. Okay. Now, one more thing you remember. When carbon is burned in open space, means in sufficient oxygen, then carbon dioxide gas is produced. But when carbon is burned, means any substance which contain carbon, when the substances contain carbon is burned in limited supply of air, then carbon monoxide is formed. So whenever we burn some different substances which contain carbon, we should burn all these things in open space. Okay, and instead of burning all these things in open space, if you burn all these things inside your room, closing door, windows, ventilation, then instead of forming carbon dioxide, carbon monoxide will be formed. And remember, the carbon monoxide is poisonous gas. It may be the cause of death of any person. Okay. I think all these things are very easy to all of you. You don't think that these are hard. And actually, you are making all these things hard yourself. Whenever you watch movie with peaceful mind, you enjoy the movie. That is why you are able to tell the story. You are able to tell even dialogues. And some of you able to remember the song contained in the movie. But what happens to you when you go for a study? You are the same person with same brain. But whenever you go for a study, you are unable to cope up. What is the reason? Main reason is that whenever you go for a study, you think that all these things written in your book, you have to remember by force, because you have to write in exam in order to get marks. Thus, you create a concrete environment which makes your mind unpleasant to cope up the things whatever written in your book. Okay, instead of that, if you think that whatever written in your book, these are the knowledge about your surrounding, and you should know about all these things, then you will able to enjoy. Whenever you will able to enjoy the lessons, then everything will be very easy for you. As for example, here you see. Now, at the top of the hill, there is a big stone. It has sufficient amount of potential energy, but we do not realize it. Am I right? When it falls down, then only we realize how much potential energy is there. Am I right? So similarly, you are also like a big stones at the top of the hill. You have enough potential energy. Simply you have to switch on it. And some of you may think that you are weak in study. Okay, no problem. You may be weak in one field, but you may have other qualities. Okay, so don't depress. Don't depress. All of you are the persons who can do everything. You have enough potential energy. Okay, but you are not realizing it. All of you are like Bajarangi. So I think all of you will be shining like a bright stars in your different fields. So good luck. Okay, we'll meet in next class. Till then, bye bye.